Hello, everyone, and thank you for joining us. My name is Katie Stolman. I'm with O'Reilly Media, and I'll be your host for today's online event. Our webcast today is sponsored by Looker. Looker brings data-driven decision-making to every level of enterprise, providing a unique data platform that adds value to data and creates a single source of truth. Looker allows everyone, on every team, to access the data needed to make informed decisions from anywhere. Currently powering data-driven cultures at more than 500 industry-leading companies, Looker is helping the likes of Sony, Amazon, Etsy, and The Economist to bring their data to life by simplifying process and introducing new possibilities for data usage. Looker is redefining data culture with a centralized data platform that allows for analytics that everyone loves. Thank you again, Looker. Today's webcast, Federating Data with Presto to build an enterprise data portal, is being presented by Todd Nemeth, Big Data Product Manager at Looker, Suraj Patel, Senior Data Analyst at Looker, and Mark Shainman, Program Manager at Teradata, covering Presto. Before I turn the program over to our presenters, I want to encourage everyone to open the group chat widget where you can interact with each other and submit questions. You can also open, move, and resize any of the other widgets. If you have problems during the event, please post a note in the chat room and one of our staff will help. For choppy audio or stalled visuals, try refreshing your browser window. And at this time, I'd like to turn the program to Suraj, who will be beginning our presentation today. Hello, Suraj.
Hi, thanks, Bert. So just to quickly go over what we're going to be reviewing today, quick look at the agenda. We're going to start with a little bit of historical context, so that everybody has a good understanding of how the technology has evolved over time and created an opportunity for Presto to be impactful at some of the largest organizations we see. Then Mark from Teradata will go into an introduction of Presto, go a little bit deeper on the technical aspects and why Teradata is making a big bet behind Presto. Todd Nemeth will walk through a demo that actually shows Looker in action, operating on top of Presto, federating data from multiple sources. And then finally, we'll wrap up the call talking about a real-life case study of a company that we're working with and how they drove adoption of an enterprise data portal across the company. Jumping right in to help everybody understand how the environment has evolved and created an opportunity for Presto. If we go back and think about how BI originated and what some of the early architectures look like, and architectures that we really see across organizations and enterprises across the globe, what we have on the left-hand side are the various source systems, and a lot of traditional systems like CRM, ERP, HR type systems, systems that really run the core of an enterprise organization. Data taken from those systems has traditionally gone through an ETL process. So the operational state of the data is not ideal for analytical reporting. So many companies stepped in the 90s to create ETL platforms that allow you to transform that data from their operational state into a state that's more ideal for querying and move that data into the enterprise data warehouse. In the enterprise data warehouse, data often resided in data marts and often in a Snowflake schema. Really informs that were ideal for querying and doing analytical reporting. And then connected to that data warehouse and to the data marts were your traditional BI tools. These are the tools that we think of like MicroStrategy, Cognos, Business Objects, tools that really emphasize the value of data modeling and allowed for cubing data for analytical workloads. So where this process started to break down was as the number of data sources exploded and more people were looking at different data systems, the basic ETL process, the process of getting data into the data warehouse in a form that was consumable by model BI broke down. Beyond the actual ETL component, the actual data modeling portion, once the data was in the data warehouse, was typically a centralized process, which also broke down as data teams were servicing queues of modeling requests. So if we transition and look at what actually happened, what we saw was you still have your traditional systems, CRM, ERP, HR. They're still flowing into a data warehouse, being transformed along the way into an ideal query-formed data. And we still have, in large enterprises, your core reporting systems running off of modeled BI tools. But what's also happened is there's been an explosion of new SaaS applications available in the market. Companies like Salesforce, Marketo have deep penetration into enterprises. And those SaaS applications, in some cases, have been put into the ETL, but in many cases, they haven't quite been added to that ETL, and the data from those systems isn't always making it to the central data warehouse. In addition, we have data coming from sensors, from logs, event data coming from web properties, and often what we see is happening is that data is going into things like Hadoop data stores. And so that's what we have at the bottom, the data lake concept. And so given that not all of these tools were making it into not all of this data was making it into the traditional data warehouse where you could have modeled business intelligence on top of it, it created a large market opportunity for an alternative way to access data for end users. And we saw many players step into it. It was traditionally serviced by something like Microsoft Excel or spreadsheet software, where people would run a SQL query against their data warehouse and get a subset of the data. They'd download data from their SaaS applications, get a subset, and they'd also pull data from their data lakes and mash all that data up in a tool like Microsoft Excel. It also created a market opportunity for other desktop-oriented tools, and that's really where we saw something like the ClickViews, the Tableaus of the world step in and create a very fast way for end users to take data from disparate data sources and visualize the data very quickly. The downside of this was the lack of the data model, as well as the limited subset of data, as many of these tools would typically be pushed in memory. So nowhere was this problem as large as it was at Facebook. So at Facebook, they had a little bit of everything. They have Oracle, they have Hadoop, they have many different data sources that live at Facebook. And so developers at Facebook working on the data engineering team created an open source solution called Presto. The idea behind Presto is now, instead of going through a process of trying to consolidate all your data in a single source, and also instead of mashing up data in an in-memory tool, a data visualization tool, you have an opportunity to have a single layer that can access disparate data sources and access them via SQL. A modeled data business intelligence tool can connect to Presto and really create what we think is the next generation of data access, which is an enterprise data portal. Now, we make a distinction between what we view as the traditional semantic modeling tools and what we think an enterprise data portal really is. In our minds, while the traditional semantic modeling tools provided great interfaces for basic data visualization and data reporting, to take that a step further, to open up the ecosystem and allow your company to be really data-driven, is to allow things like data scientists to access data through the semantic model and allow the creation of data-driven applications. So we've talked to a lot of companies who talk about the painful process that a data scientist will go through, downloading raw data into an environment like Python, manipulating that data to get it to the form that's ready to perform sophisticated analysis. And a lot of that pain has been alleviated by the fact that they can access data in an already modeled fashion. And similarly, imagine a world in which your Marketo system is able to access your most valuable customers based on what the data is telling you. That's what we envision from data-driven applications. So I'm going to pass it over to Mark, who's going to go a little bit deeper on Presto.
Sure, thanks. So I'm going to touch base on Presto and give you a little insight into where Presto came from and what the roadmap is going forward with Presto. So you understand, Presto is a 100% open source SQL on Hadoop engine. It was built by Facebook. So, Facebook originally built out Hive, and they were leveraging Hive within their infrastructure. And after a while, they realized they needed something that was higher performing and more interactive in nature. So what they did is they got some guys together and they took standard MPP database architectural principles and actually built out the Presto query engine. And it's built on a very, very modern code base leveraging Java. And, of course, at Facebook, they use it at petabyte scale. So it has real proven scalability, and it's based on a full in-memory interactive solution set. So it's very, very high speed for interactive queries and cross-platform capabilities. So not only did they architect it to be this high-performing engine for their SQL on Hadoop environment, as mentioned earlier, Presto actually has an adapter-based, a plug-in adapter-based architecture that enables it to query other data sources as well, such as Cassandra, Kafka, MySQL, PostgreSQL, Redis, MongoDB, and some other ones, some adapters that were developed by the open source community are in development right now. Elasticsearch is in development. Accumulo is in development by Bloomberg right now. So there's a number of plugins that enable Presto not only to get that interactive query capability against SQL on Hadoop data, but also other data sources. And it's actually used by a large community of respected technology companies. Initially, you saw the early adopters, your Facebooks and Netflix, and your Airbnb and Dropbox, but now you're seeing companies such as NASDAQ, Bloomberg, Comcast, all looking and putting Presto into production environments in their analytical infrastructures. So a little on Teradata and Teradata's contribution to Presto. Over a year ago, Teradata actually, ponied up and agreed that we were actually going to be a major contributor to the Presto code base. We have 20 full-time developers dedicated to contributing code to the open source Presto project. And anything that we develop for the core engine is contributed right back into the main branch. So when we first went out with a roadmap of contributions to Presto, in our phase one, when we looked at what was out there for Presto, we realized that some of these bleeding edge tech companies were leveraging Presto, but the normal companies weren't leveraging as of yet. So they needed some basic things, such as an installer, documentation, some monitoring support tools. Those were some of the first things that we came out with to support Presto. Our phase two, which actually we released at the end of last year, we actually came out with a management tool integration. We came out with Yarn integration and Bari integration, as well as an enterprise-class ODBC driver. And this was a key thing because there had been an open-source developed ODBC driver. It wasn't stable, didn't work very well. And in developing and coming out with an enterprise-class ODBC driver, it enabled major BI companies such as Looker to start leveraging their tool sets on top of Presto. And so we've seen a large number of BI vendors now certify on top of Presto. And then around June of this year, we came out with another release. We came out with an enterprise JDBC driver. As I mentioned, BI certification, and Looker was one of those BI tools that actually is fully certified on top of Presto. We came out with some security enhancements, role-based security. You can now run Presto in a Kerberized cluster. Query grid integration, which is actually connectivity to the Teradata data warehouse, that enables existing Teradata customers to query from their Teradata data warehouse into Presto, and then Presto can query any of its data targets. And then cloud features as well. So we actually have a customer who's running Presto in Amazon EC3 against EMR as well. And all during that period of time, we were coming out with expanded ANSI SQL coverage. And one of our goal sets is, in working with Facebook, is to have Presto fully able to run the TPC-DS benchmark without modification of any of the queries by the end of this year. And so that's one of the big goals. Some of the other big things that are on the roadmap coming forward are intermediate result set spill to disk is one of the things that's on the roadmap. Facebook and Teradata together are really working on a new advanced cost-based optimizer, and of course always expanding SQL coverage, etc. Teradata actually, so Presto is actually released, and you can go to GitHub and grab a release of it on a weekly basis. But what Teradata actually does is we actually take a release, we go through a bug fix and stabilization process, and on an every 3-month basis, we release a Teradata distribution of Presto. And sometimes some of the functionality, like for example, the Kerberos support first came out in our distro, and then we gave it back to the main branch, and later it came out in a later release of the main branch. So we come out in every 3-month version. We offer enterprise support for that version, and we find that other companies that aren't the bleeding edge companies like that release cycle versus trying to go to GitHub every week and try to grab a version that might break something else. So we actually go through that certification process. So there's a lot of things on the roadmap coming up for Presto, a lot of performance improvements and enhancements. And the number of companies that are really leveraging Presto and jumping on board, it's a great community and continues to grow.
Thank you, Mark. That's a great overview of the work that Teradata is doing with Presto, and yeah, I think that it's really good. This is Todd Nemeth, by the way. I'm the product manager for Hadoop initiatives at Looker. Let me share my screen. I'm going to give a demo here real quick. Can you see it? Other people who can talk?
Yep.
Okay, thanks. But yeah, I think just kind of emphasize what Mark just said. The work that Teradata is doing is I think really going to help increase the adoption of Presto. I mean, I think Presto is really good technology on its own, but doing things like Yarn integration is going to help people stick it in their Hadoop clusters and be able to have it play nicely with other applications that already exist, and then it can work in a Hadoop queue, and being able to put it in Cloudera parcels, releasing it with Cloudera parcels is going to be able to make it so that you can roll it out in the normal sort of Hadoop rolling upgrade ways that you've already set up in your existing cluster. So I think that's one of the few things that's holding back Presto adoption now, and Teradata is taking care of that kind of stuff. So it's really good work. Anyway, so what I wanted to do was show some of the Presto sort of in action, searching different data sources and then combining them. This is one of our standard demos. If you were at Strata in the UK earlier this year, then maybe you've already seen part of this demo. This contains 5 years of data from 2009 to 2013. Wait, that's 5. Anyway, it's taxi data from Manhattan. It has contains pickup time, drop-off time, location, number of passengers, tips, distance, that kind of stuff. This is stored in a Hive table. It's partitioned by day. It's in the ORC format. And then what we did was we downloaded some weather data publicly available, massaged that. We got hourly readings, so we got temperature, precipitation, weather conditions, wind speed, all that kind of stuff. That's stored in MySQL. So, and then we're using Presto to sort of federate between the two data sources. So that's the that's what we have to show here. I was hoping to get some internal, some customer stuff, but they weren't too eager to show what they had. So, so we're going to look at this instead. So, for example, so here's some. Oops. Here is a dashboard, for example, that we have that's built out of this. So we can take a look, and so this is Looker, by the way. What we're looking at is the Looker demo instance. And so what you can see here is different visualizations, some involving maps, some involving, some bar charts and line graphs. So here's something, for example, daily ride pattern. This only involves taxi data. So we can take a look at, for example, here are the weekdays. So from midnight to midnight, how people are taking taxis. And we can compare that against like the profile of, what weekends look like. So here's an example of Presto doing a search against Hive data and, working well. But then, for example, that we can do more interesting things, right? If we look at, if we federate this with, for example, some temperature, some weather data. So here's a very similar view. And now what we're looking at is what's called a look, or sort of a visualization. A look with a visualization. And now we're looking at, again, midnight to midnight, but instead of blowing it out by week, we're looking at it by tier of temperature in Celsius. So we can look at, for example, from weather, right? So if it's 30 degrees Celsius, which is, I think, like about 90 Fahrenheit, at 7 in the morning, people are like, maybe I'll take a taxi instead of riding the subway, right? Or 8 in the morning, which is probably a pretty good idea. And then if you look at sort of the lower temperatures here, like -5 Celsius, then in the afternoon, people are more inclined to take a taxi versus earlier in the morning. So you can start to get these kind of insights. But what's going on really, behind the scenes is Presto is joining the two, and I'll show that a little bit later. I just want to show some more visualizations here really quickly. Here's another interesting one. This shows some of Looker's mapping capabilities. There we go. So this is kind of interesting. So what we're doing is, well, here, let me show this first. This might be. So we're looking at the pickup location, the drop-off location. Some of this obviously doesn't have any location, and some of them are too close to have any distance. And we're looking at the most popular, the 2,000 most popular. And then we're looking at a percentage of rides with weather. And basically what this means is what is tagged that has rain or snow going on at the time. And we're looking at the percentage of that. Okay? And then we're going to map that. We're going to put that on a map, right? And then we're going to look at it. And so basically, whichever rides have a higher percentage of times that the people have taken that ride when it's raining or snowing out, then it's colored purple, and sort of the lower it goes, then it's colored green. So you can see sort of a profile that if it's raining or snowing, people are more inclined to jump in and just kind of take these shorter rides across Manhattan. So again, different interesting things that you can pull out through Presto's federation. The other thing that I want to show is the SQL that gets generated for this. Oh, and this is filtered to the year 2013. So this is a year's worth of data that this was crunching through, right? So so as as Mark pointed out, still working on the TPC. Complete compatibility, but still, you can get some fairly complex, SQL support, through Presto, whereas, some of the SQL on Hadoop dialects have sort of a reputation for not having very good SQL support. I think Presto probably has the, is one of the better ones. Okay. Another dashboard, again, because this is time series, we can go back and look at specific events. So here's, just one more quick example before I jump into some of the more guts. Here's Hurricane Sandy. So So you could look at like the amplitude is the number of taxi rides, and then it's color-coded to wind speed. So you could see how taxis drop off as the wind speed increases. Here is taxi rides, and then here's snow and heavy snow, and you can see that drop off. You can see how tips increased like after the blizzard. You can see here people had the Christmas spirit here after the blizzard, and you can see, for example, how the distance and the duration were affected by Sandy as well. It took longer to get places, obviously, after the blizzard and after the hurricane. So again, different insights that you can pull out. So how do you model something like this? Let me show you in Looker. So in Looker, when you're going in to join tables or to do something like this, right? Let me zoom in a little bit so you can see this better. So here we are, we're looking at the table. Here's rides, and we're joining this in. And so this is a markup language specific to Looker. It's called LookML for Looker markup language. And so we're joining this, and we're joining weather, which is the other table, and we're saying to join this, on the hour. So we're going to chop off the hour of the pickup time, and we're going to combine, and we're going to join that in with the weather. And this is a many-to-one join that we want to have, right? And then we can add some other things. For example, we want to cache this so that we don't crush my poor little cluster. And also, we want to make sure that we filter this. So if somebody throws on some kind of select star or something like that, or select something, it will always put on a filter so that it just gets one month by default. So so again, even though it's two different data sources that we're federating over, in the model, it looks like we're just looking at two tables in the same database. And so how do you join in a table like that? Here's where we can go in Looker, and Looker will connect into Presto via that JDBC driver that Mark mentioned, and it will go through and it will walk the catalog, and then walk through the different catalogs. All the different connections are called catalogs, and here are the Hive schemas, and then it will also go through, and the MySQL one is referred to as weather, and so here's the MySQL connection. Here is the MySQL weather, and then by clicking on that, then it will go in and it will just basically add all the information that it has about that MySQL table, and now that's part of my model, and then I can put that, right? So I mean, in this case, I've re-added it, but that's basically the way it is, right? So you could, that could be some other data source, right? So you could imagine adding in other things like, what I've seen is, people adding other public data sources like census data, demographic data, social media stuff. I've seen machine data like, like web stuff, app data. I've seen structured lookup data like users, organizations, companies. People look up user agent information against their web logs or cookie lookup data. There's interesting things that you could do. For example, Kafka, start looking at the other end of the data pipeline with streaming and stuff like that, right? So, so that's the kind of stuff you could start to bring into your data model, and you could start modeling, visualizing, and then reporting, with Looker, with business intelligence tools. So, so that's what I wanted to show. I sort of did it backwards. I showed first the dashboard, the visualizations, the SQL, then the model, and then how to bring a table into the model. But that's what I wanted to show. Let me pass it back to Suraj now.
Thanks, Todd.
All right.
Just
There
give
you
me
go.
1 second
Sure.
while I pull up the presentation here. Great.
Okay.
So now that you guys have seen Presto and learned a little bit more how it works at an abstract level, I'd love to talk everybody through a customer story, a real-life implementation where we have Lookers sitting on top of Presto, as well as a couple of other data sources at jet.com. So for those of you who are not familiar with the Jet.com story, it's a really impressive company out on the East Coast, raised over $500 million in venture funding, and have a big vision of taking on and redefining the e-commerce industry and saving consumers money. So they have a marketplace model where different merchants can come on and basically provide inventory for different SKUs, and consumers can purchase from them. In terms of what their actual technology profile looks like, often when we talk to companies that are a little bit younger but at significant scale, what we find is that they're leveraging the cloud for operational efficiency as well as cost effectiveness. And so Jet.com is no exception. They have their entire infrastructure in the cloud, and for Jet.com, given the competitive nature of their business with Amazon, they really had to look beyond AWS, which seems to be a default for a lot of people. And they found a great fit with Microsoft's Azure platform. So their entire BI stack and their data stack, it all lives in the Azure platform. And what they have is they have data being ingested through a variety of different technologies, but a lot of reliance on things like Storm, Kafka, very modern data pipelines, and an event-based architecture that enables for both kind of slow latency reporting as well as real-time reporting. So, and then just to speak to the cultural environment at Jet.com, it's a very, very tech-savvy culture. We've heard stories that almost every employee is encouraged to understand SQL and really be a data-savvy, forward-thinking culture. So given that everybody knows SQL at Jet.com, you may wonder, why would they come and look to change the way that they're approaching their data-driven culture? And there are multiple reasons why they came to us looking for a change. Their current process looks something like analysts across the company would create dashboards using custom SQL and D3 JavaScript visualizations, and every Monday when they did their weekly reporting, they would talk through their custom dashboards. One of the issues was that all of those custom dashboards had to be custom built, of course, and what that meant is every single category manager was building their own dashboards, which was creating a lot of duplication of the work. But really, what it came down to, beyond duplication of effort, was the fact that there was no consistency across the organization. So some category managers were defining a metric a certain way, and other category managers were defining that same metric in a different way. And to make matters worse, analysts that weren't on the core data engineering team, while they were very capable, because their everyday job did not revolve around the management of data, oftentimes they would write SQL queries that maybe were not the most efficient or the best way to get to the data that they needed. So the data engineering team at Jet.com said that they wanted to solve two core issues. One is they needed to stop all this individual query writing. What they needed to do is have a single source of truth so that a metric was defined once and never had to be defined again and differently for different categories. And then the second thing that they needed to do is they needed to garner operational efficiency. So in order to do that, they needed to have people stop duplicating efforts, and they needed to have a tool that people could use to get the data that they wanted. So to oversimplify an example of what their architecture sort of looks like, the idea is the slide before where I mentioned how Presto really evolved. So again, they have data that lives in three main sources. They have Azure DW, they have traditional SQL, and then they also have data that lives in Hadoop. And what they're doing is they're leveraging Presto as one of the ways to query that data and really allow them to have a single place where people can go and access that data. And then In their case, they're using Looker as their enterprise data portal. And where it started in terms of their adoption of an enterprise data portal is they've started with data visualization and reporting. Their data scientists are starting to adopt Looker and access the data from Looker's RESTful API so that they can move data straight into the data science environments they want. And then there's a forward-looking vision of how they can create data-driven applications. What's interesting is the adoption pattern that we've seen across the organization. So at Jet.com, they started with a proof of concept, and that really revolved around basic sales analytics. And this isn't too different from what we see at organizations we engage with. Sales is a very data-driven environment where people are either making their sales number or not making their sales number, and really guides the entire company. So a great place to start are those key sales metrics. From there, they started looking at product metrics. Again, the advantage of connecting to Presto is that it also is a SQL on Hadoop interface. So all of the different event data that helps them understand how different product releases are actually affecting consumer behavior, all of that was enabled by putting Looker on top of Presto, which accessed the event data in Hadoop. Then they moved on to the inventory data, getting a good understanding about how inventory is moving through their supply chain. So how long it takes an item to get from a distribution center to actually into the consumer's hands. They've moved beyond that now into financial modeling. So a lot of the analysis that their FP&A team does, now a lot of that data is sourced in Looker, and even some of the business logic that they use has made it into the Looker data model. And then finally, we've gotten to the point where even their business development team feels enabled and empowered to access data for their conversations that they're having with their merchant or retail partners. And they're able to use Looker as a way to access data and have a more informed conversation with merchants about how the product that they're selling on Jet.com is actually performing. So if we generalize what we've learned from the Jet.com story into more broadly how we can drive adoption at different enterprises, what we found is that there's certain keys. We've seen a lot of BI projects fail, quite frankly. And a lot of times when we see those BI projects fail, it's because, one, there's not consistency across the organization, something that we talked about before, but really falling into the trap where you have metrics defined in one BI tool that don't match metrics defined in another BI tool. Second, they lack process. So there's no clear plan on how you roll out a BI tool from a department to the next department. There's no good process around defining the metrics, building consensus, and then executing on your plan. Oftentimes, people try to do too broad of a project. So at an organization that's been around for 20 or 30 years where you have the traditional ETL that's creating modeled data environments for your FP&A team, but then you also have lots of individual departments that are doing BI departmentally, it can often be a mistake to tackle the entire organization at once. Where we see organizations be most successful is to go after departments that have low-hanging fruit, are forward-thinking, and are really, a somewhat small footprint within the company. And then beyond that, you expand. Now, a lot of key to having a successful expansion is to operationalize the data. One of the key tenets at Looker, and what we believe all modern data portals should really emphasize, is that data should no longer be just something that we look at reactively. And what we mean by that is our Salesforce that's on the ground, they should be able to see the data contextually when they log into Salesforce. Leverage data that's been modeled, but then have an API that allows them to see that data where they're actually having conversations and making decisions. Companies that use modern collaboration tools like Slack should not be forced to log into a BI tool every time they need to make a decision that revolves around data, but rather that data should be able to be accessible directly in Slack. And lastly, we shouldn't be, again, reacting to data. We should be proactive. So using things like intelligent alerting and webhooks to actually monitor things that are happening operationally in our companies. And a great example is a different e-commerce company that we work with that has same-hour delivery. Monitoring inventory and automatically taking off a process to remove a SKU from a mobile application if the inventory happens to be running low. And then once you've operationalized that data, that really is how you open the door for expansion and a continual iteration of this process as you expand across the organization. Now, finally, just to reiterate some of the keys to expansion, the first step is to identify the right departments. Again, a couple of things make a department a good candidate for moving to an enterprise data portal. The first is that they have a lot of data needs. This should be a department that's producing a lot of data and on the same vein has a lot of opportunity to make a difference in their performance based on data. Often we find that these departments are relying too much on desktop-oriented analysis done in Excel or desktop visualization tools, and really are low-hanging fruit for creating a modeled data environment. Find key data leaders in that organization. So at the end of the day, accountability for a rollout is really, really critical. You need to have a strong technical leader who will take ownership over the data model and empower the rest of the organization or the rest of the department to access that data. Finally, once you've found the right department and found the right leaders that are going to drive change within that department, you execute by actually going out, you define the key metrics, determine what the right business logic is for those metrics, and model it into the semantic modeling layer. Once you've modeled it into the semantic modeling layer, making that logic accessible to the rest of the organization is also key. So we've talked to various companies that do this by having a data dictionary that lives somewhere in a wiki-type format. We've talked to other companies that actually build that logic into their enterprise data portal. So in Looker, for example, you're able to put that logic in human-readable words as a tooltip so that people immediately know the logic behind the metrics that they're selecting. And the only way you have successful adoption and the ability to expand past that single department is to obsessively look at how we can make that first early adopter department successful. Make them a poster child for the right way for different departments around the organization to use data, and make them the thought leaders. If you do all that and fuel the grassroots adoption through data operationalizing the data, that's how you're able to drive adoption and really expand across the organization. So with that said, we've covered the material that we had planned for the webinar. We'd love to open it up for any questions that you guys have.
And once again, to remind the audience, if you do have questions for our presenters, you can either type them into the group chat, just put a capital letter Q in front of it, or you could submit them via the group chat widget. I'm sorry, the Q&A widget. First question, though, we do have, is Presto open source?
This is Mark. Yes, Presto is a full open source engine. You can download it for free off of our distro at teradata.com/Presto or off of GitHub, either one. It's licensed under the Apache license.
Yeah, and I would also recommend joining the Google groups for the Presto Presto database, and then there's one for Teradata.
what is the latency profile for ad hoc queries by Presto over petabytes of data?
Yeah, that depends a lot. You know, we were talking about this yesterday, sort of in the pre-call. Presto likes to have a lot of memory. You know, so it depends a lot on the memory and sort of how the cluster is provisioned. I also think that it depends a lot on how the underlying data is structured. You know, so you could do things like date partitioning. You can do things like, you know, Parquet or ORC. You know, stuff that helps with like predicate pushdown and, you know, things like that. So it's a difficult thing to answer in a general way, but you know, there's sort of general best practices that you can do, but you know, there are a lot of things that you can do to speed it up. But I don't have like a general rule of thumb that I can share. I don't. Mark, do you have anything?
Not general. I mean, it varies so widely based on the type of query. How much data is the query bringing back? What's the query doing? Are you doing partition elimination? You're leveraging ORC versus Parquet? Tons of things. Just for edification, you know, 3 years ago, or maybe not even 4 years ago, Presto was being run at Facebook on a 400 petabyte environment. So you could just think that was 4 years ago, what they're actually running it against today. So they run it on a huge scale against huge amounts of data in their environment.
True.
We have a question asking if you can comment on how Presto/Hadoop are versus Spark.
I guess. Do you want to take that, or I can take that? Or I can take a component of it.
I'll take a whack at it, and then you can clean up. So, so Presto is a bespoke like MPP SQL engine, right? So Presto was designed from the beginning to do SQL in an MPP way, and you know, and join, you know, federate data. Spark is, you know, multi-purpose with many different APIs that can do graph analysis. It has R hooks, you know. It can do SQL. You know, it can do a lot of other things. Oh, machine learning. I'm sure I'm forgetting some of the other APIs. You know, so it has a lot of things it can do. You know, it can do SQL. You know, Looker supports Spark SQL as well through JDBC driver, you know, through the Thrift server if Hive is compiled in. You know, so if we just sort of separate out the two, you know, Spark is slightly more popular than Presto right now. I think just because Presto hasn't been around as much. Presto in terms of queries swamps Spark, and so maybe in some ways Presto is more usable or has gained more adoption within organizations. You know, like, you know, if you look at that jet.com use case, that gives you a hint right there. But you know, I guess you think of Presto as a sort of a, you know, one use tool, and think of Spark as like a Swiss Army knife.
Yeah.
Anything you want to add?
I agree with that. Yeah, you know, when you look at what Spark can do for a data scientist as a general purpose platform, and their RDDs being able to bring that memory, that data structure in memory, it's great. But even with what we've done, when you look at SQL compatibility, you know, Presto blows Spark out of the water. Just performance for SQL workloads, you know, Presto is much more performant than Spark SQL. You know, that's, you know, what, you know, when you try to bolt on a SQL, you know, engine on the top of a general purpose platform versus something that's kind of architected from the ground up just to do SQL, there's going to be a delta in functionality and performance. And that's what we've seen in our own testing. You know, at Teradata, we support Spark. We think Spark's a great engine. But when you're looking at doing SQL on Hadoop or querying federated query type workloads, you know, Presto, we would recommend Presto over Spark.
Yeah, and this is outside of the BI realm, but, you know, in Spark, you know, you can do SQL in the API. So it's like kind of cool. You know, you have a data set, it's in an RDB, then you know, stick it in a data frame, run some SQL on it, and then, you know, stick it back into a data frame, run some machine learning on it, do it all in Scala. You know, that's some pretty cool stuff. You know, you can't do that with anything else, you know. So there's Spark is really awesome. You know, I don't want to put Spark down at all.
Another question, does the Presto Looker, does that eliminate the need for Alteryx and Tableau and similar tools?
Todd, I'll take a shot at this, and you can.
Yeah, go ahead. Yeah, thanks.
Yeah, so the short answer is yes. I would say that what we see with Alteryx and the Tableau model is Tableau approached the market from a standpoint of, you know, you could have model-free data analysis. And what they found at an organizational level, oftentimes there's certain transformations that need to be performed that you can't necessarily do in memory. And so the one option is to create an SQL view file and point Tableau at the SQL view file. Another option, and this, I think the reason why this is gaining popularity is because of the drag and drop capabilities, but you basically have a visual data prep tool, which is Alteryx. And so in combination, you have the data prep done by Alteryx, and you have the actual visualization of Tableau. And we think that what that does is it solves kind of the first box of what we imagine an enterprise data portal is. But what we think the difference and the advantage of going with something like Looker and Presto is, one, the commitment from Teradata as well as the open source community to continually evolve Presto, continue to expand the data sources that it can query. And as the data world evolves, we imagine that Presto will become a tool that continues to evolve with it so that you're able to access data across your organization continually through this single platform. And then the semantic modeling of Looker, which is really a late binding model or late binding transformation model where you actually leverage the power of Presto to transform the data and prepare it for whether it's data analysis, data visualization, or things beyond it where you're able to use Looker's RESTful API to leverage data in a data-driven application, or a data scientist can use Looker's API to leverage data in a data science environment.
Let's see. Is Presto being used in any industry benchmarks?
I'm gonna let Mark take that one if he can.
Okay, yeah. There's been a number of benchmarks, and actually tomorrow, Teradata is actually doing a webinar. We actually had an independent third-party Radiant Advisors do some benchmarking on Presto versus Impala versus Spark SQL versus Hive, and we're presenting those results tomorrow. So, you know, what we saw out of the benchmark, you look at Impala and Presto, and they're the highest, the high-performing engines, and Hive and Spark SQL were not as performing. But for all the details, you can attend the webinar tomorrow.
Oh, that sounds really good. I wasn't aware of that. I think, the benchmarks are very useful as data points. What I found is that the use cases are so widely varied that they're not always directly applicable to whatever somebody's trying to do.
This is Mark.
I guess that it's more directional, I guess, is what I'm trying to say. But they are very useful, like data points for comparing engines and their strengths and weaknesses.
And this is Mark again. And it also depends on the workloads as well. I mean, something like Hive is great for your large batch jobs because it actually saves intermediate sets to disk, which is great if you're doing big, huge batch jobs. Not the best for interactive ad hoc queries, but much better than a Presto or Impala for your big long-running batch type workloads. So it all depends on your workloads and what you're doing. And your environment could be very different than running the TPC-DS benchmark. So that's one. To always take them with a grain of salt, but they are something to give you some insight into maybe SQL compatibility and usability, et cetera.
Yeah, I'm always glad to read them when they come out, so I'm looking forward to it.
We have a question. How does Presto play in the world of cheap relational MPP databases like Google BigQuery and Redshift?
I'll answer quickly from a Looker standpoint, just what we've seen. I would say we've seen organizations be incredibly successful with both, especially where we see a Google BigQuery Redshift being a solution where the entire organization's data is in one of those databases is an organization that typically is younger. So we've seen some of the younger organizations we work with, they can put all their data in something like a Google BigQuery, Amazon Redshift, Azure DW, versus the older companies that have been around longer. They have existing other data warehouse solutions. They have Hadoop distributions that have a lot of data, and sometimes it's not practical. Even at the price point and the efficiency of modern relational databases, it's not practical to consolidate all into that.
Yeah, I agree. And I would say with BigQuery is like a completely different sort of beast. Like, you don't have to worry about how many servers. It's like serverless architecture, right? And you just pay by the query, so you just throw your data in there, and then you don't worry about anything. And it's a very interesting pricing model. And we've seen companies have great success with it, and then and then it can be interesting because you throw it out to the entire organization, and then they get unexpected costs. But also, you don't have to worry about servers or maintaining any of that stuff. So it's an interesting thing, that sort of came out of nowhere. That's getting a lot of adoption. But yeah,
Mark,
Redshift. I'd say Redshift is the bread and butter.
Yeah. Mark, I'd love to hear your opinion, given that Teradata also has Aster. When do you guys guide people towards Presto versus a analytical database like Aster?
Yeah, I mean, Aster is really for doing big data analysis. If you're doing things such as NPath analysis and graph analysis and all that, which you would traditionally think of, what you would leverage Java and MapReduce within in a Hadoop environment to do. We have a language called SQL-MR that allows you to write a SQL language and execute complex, MapReduce jobs against data sets. So if you're doing that big data analysis, we lead people toward something like an Aster Data. And we actually now Aster Data runs on top of Hadoop as well. So if your data exists in Hadoop and you want to run that type of workloads, you run it and you can run Aster on it. But if you're doing SQL, you're doing SQL against Hive tables that exist within a Hadoop environment, and then we recommend our customers in interactive workloads, and we recommend that our customers look at Presto, as well as if you're looking to, as you mentioned earlier, federate data. If I want to bring in some data that exists in MySQL and join it with that data that exists within my Hadoop environment within a SQL query, that's where we would lead people in the direction of Presto.
And it looks like we have time for one last question. How long does it take to get something like this set up? What are the technical requirements?
So you're
Mark,
asking from a
to...
Presto perspective? Sure. Setting up Presto is not extremely complex. There's an installer. I mean, you can just go to Teradata, www.teradata.com/Presto. And if you have no Presto experience, you can actually download a VM, either a Horton or Cloudera VM that contains Presto and some data and some things to actually get started and play around with it and query it. And then when it actually, the setup process of Presto, isn't extremely complex. You can actually install it on all of your data nodes, depending on your environment. I mean, things you have to take into consideration is what other processes am I going to run it in it within, a Yarn container. So some of the things to take into consideration when setting up your environment. And then Presto uses the Hive metastore to actually understand what tables and columns and rows exist within the Hadoop environment. So it's necessary to have the Hive metastore there as well. But all the documentation is available for download on teradata.com/presto. And the first thing that I recommend is try downloading the VM or download a copy of Presto and install it, and because it's free, and start playing around with it. As mentioned, there's a Teradata email list that you can actually ask questions, as well as the Google group as well. And you can get started. We have people who've gotten up in testing environments within a very short period of time, within days.
Well, thank you so much, Suraj, Todd, and Mark, for being with us today, for presenting such an outstanding webcast and sharing your knowledge and expertise with our audience.
Oh, thank you. Thanks for your time. Thanks for everybody for attending. I hope you found it useful.
We'd like to thank all of you that attended our webcast today and hope you've benefited from it. Today's webcast was sponsored by Looker. Looker brings data-driven decision-making to every level of enterprise, providing a unique data platform that adds value to data and creates a single source of truth. Looker allows everyone on every team to access the data needed to make informed decisions from anywhere. Currently powering data-driven cultures at more than 500 industry-leading companies, Looker is helping the likes of Sony, Amazon, Etsy, and The Economist to bring their data to life by simplifying process and introducing new possibilities for data usage. Looker is redefining data culture with a centralized data platform that allows for analytics that everyone loves. Thanks again for joining us. This will conclude our webcast today. Goodbye, everyone.